Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. The problem is fruits into baskets. You are given two arrays of integers, fruits and baskets, where fruits I represent the quantity of fruits of the ith type, and basket J represent the capacity of the jth basket. From left to right, you need to place the fruits in the baskets according to the some of following rules. Okay, so each fruit type must be placed in the leftmost available basket with a capacity which is greater than or equal to the quantity of that fruit type, and each basket can hold only one particular fruit type. If a fruit type cannot be placed in any basket, it just remains unplaced, and you need to tell the number of fruit types that remain unplaced after all the possible allocations are made. So how does this work actually? If you see, the fruits we take to be something like 4 to 5. These are the fruits which you need to place in some baskets, right? So what was the basket here? 3, 5, 4. So 3, 5, 4. So you will scan each fruit one by one. So for this fruit, you will see which is the leftmost basket which is greater than this number. Okay, so that's 5. Okay, 3 is not greater. Then you go to the next index and see that 5 is greater. So you are able to place this fruit in this basket. Okay, now you will scan to this fruit now, this fruit which is 2, and you will find the leftmost empty basket. So you see 3 is the leftmost, which is also greater than 2. So now 2 you put into the 3, and 5, you see you are now remaining with 5, but all the remaining elements, these two baskets have already been used, the first basket and the second basket. Only the third basket is left, which has a size of less than 5. So this you cannot place it in there. So this last type of fruit remains unplaced. Okay. So this last fruit remains unplaced, and therefore you don't have any choice but to make it unplaced. And one will be your answer because only one fruit remains unplaced. Okay. So this you can do in a simple O of n square solution. Okay. So what you can do is that you can simulate the whole process. You can, for every, you can start an index. Okay, you can start an index from I equals to 0 to I equals to n. Okay, for every fruits of I, what you can do, you can have another loop j which will also go through the baskets. Okay, j equals to 0 to n, both both arrays are of size n only, and this will go through the baskets and just tell you that which is the first basket which is just greater than or equals to these fruits. Okay, which is the first basket which is just greater than or equal to this fruit. And if you get such a kind of basket, you just place it, and if you are unable to place it, you just increment your global variable answer by 1. Okay, so let's see how to do it. Now this, the constraint you see is only 100. So easily a O of n square solution with work. But if it was something like 1e5, if the constraint were something higher, then this problem will be a totally different problem. You will need some things like binary search or segment tree to solve it. So let's not go into that much detail here because it's just 100. Even O of n cube will work, but O of n square, let's see how much percentage bits it just gives you. So let's see the solution first of O of n square. So there is another problem of fruit basket 3, I guess. So you can just go ahead and try it on your own if you already know the segment tree. So yeah, segment tree cannot be taught in just like simply one video. You just, I mean, there is range updates, there is range queries, there's a lot of things that you need to know. So if that comes in tomorrow's daily challenge, I will just try to use the template to solve it. Okay, so I will just uh, into for today's task, I will just tell you to learn the segmented theory. Okay, so as of now, I am just solving it using O of n square solution. Okay, so let's see what we can do. We have an answer variable also. As I told you, for every fruits, I will scan each fruit one by one. So as I'm scanning each fruit one by one, I will also go through the baskets. So I will keep a flag. Okay. This flag will tell me whether I am able to place this basket or it is still unplaced. Okay. So if I am able to place it, I will change this flag to 0. If it is still unplaced, I will just increment my answer variable because I need to count the number of unplaced fruits. Okay, so if flag is still true, you just increment your answer. And what you need to do here is that you go through all the baskets and check if that the baskets of J is something greater than equal to fruits of I. So for each fruits of I, you go through all the baskets from the left, and you whenever you find the leftmost basket which is greater than the capacity, which has a capacity which is greater than the number of fruits in the ith fruit type, what you can do is that you can just take, you can just take all of the fruits. You can just put all the fruits in the basket, so such that the basket capacity is now zero. It does not have any basket. Okay, it does not have anything to place in this capacity, and you will reduce the flag to zero also. And also, you just break from the loop because you have found the first index, and you are able to put all of the fruits I into the baskets of J, and you just now need to break from the loop. Okay, so and at the end, if you could not set the flag to zero, it will remain one. It will indicate that you have not found any baskets of J which is greater than fruits of I, and therefore you need to set the flag. Okay, you need to the flag is set as, so you need to increment your answer. What you can do is just return answer. Okay, so let's see. It is as accepted thing. Let's try to submit it and check. So it is giving me a 57% bits approximately. Okay, so this is a little, I mean, unusual because in different runtime it will give you different percentage bits. See, so you see in the third run, in the same code, it is giving you 100% bits even with an O of n square solution, although an optimal solution is possible. So let's say I will tell you to try this second problem also. Okay, this fruits into basket 3, there is a third version for this. You can just go ahead and try that. Okay, and before that, if that comes into tomorrow's daily challenge, I will not be able to show you the complete theory behind segment tree. Okay, because in one video it is not possible to cover the whole of segment tree. So I will just show you directly the approach, the method, if it comes in tomorrow's daily challenge. So because I'm not having that much of time that I can make a 1.5 hour or 2 hour video explaining completely the segment tree and then again going to the solve the problem. So I will just suggest you to solve. See how to solve. See about the theory. See about the theory of segment tree. Okay, just see the theory of segment tree. What all you need to see? Range query. How to do range query? Okay, how to do range update and how to do range query and update. I guess this will work. This will completely work. So these two things you should see. Okay, and binary search, I hope you already know it. So if you do not know segmentary, just go and quickly check about the theory so that if this third version of the problems comes in tomorrow's daily challenge, you will be able to, you will be well equipped to understand the solution, and you can also go ahead and try the next problem if you have understood the theory. So yeah, that's all for this video. I will keep it short. Okay, so yeah, that's all. I hope this was definitely an easy problem to solve given the O of n square solution, and I hope your day goes as easy as the problem. Thank you so much.